find the second derivative of this function. We've got f of x is equal to x minus 7 over x plus 3. Well, first thing, I notice this is a quotient. We've got something divided by something else. So the top part I'll label as p, the bottom part I'll label as q. Now we need to find p prime. Well, the derivative of x minus 7 is 1, and we need to find q prime. The derivative of x plus 3 is 1. Now our formula for the quotient rule is p prime q minus p q prime all over q squared. So for our first derivative, p prime we said was 1, q was x plus 3, minus p, which is x minus 7, times q prime, which is 1, all over q squared. Well, the 1 isn't doing anything in either one of these, so this becomes x plus 3. Now remember, a negative out in front of your parentheses flips the sign of everything inside, so it's going to flip the sign of the x and a negative 7. So that gives us a negative x plus 7, and then x plus 3 squared. Combine to get like terms. The x and negative x is going to cancel, and 3 plus 7 going to give us 10 over x plus 3 squared. Okay, now there's two different ways you could take this next derivative. You could do the quotient rule again. Top part's p, the bottom part's q. Or you could take this entire part and move it up on top. And it becomes 10 times x plus 3 to the negative 2. So then, for our second derivative, numbers out in front just stay out in front, so that doesn't change anything. Notice we have parentheses to a power. This is the chain rule, the general power rule. So 10 stays out in front. Take our power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. Let me go over that again. The chain rule, the general power rule, take your power, put it out in front. That's what negative 2 is. What's inside the parentheses remains as is. Lower your power by 1. So we got negative 2 minus 1 times derivative of what's inside the parentheses. Well, 10 times negative 2 is negative 20. X plus 3 to the negative 3 power. The derivative of x plus 3 is 1. Now I want to move that x plus 3 to the negative 3 back down to the denominator. Move it back downstairs. And it becomes x plus 3 to the positive 3. It's kind of small, isn't it? Let's try it again. There. A little bit better. Not much. Now, that's one way. There would have been nothing wrong with using the quotient rule again. Just for fun. Let me show it. This is our answer. So not confuse that. But let's say I decided this is my first derivative. It's equal to 10 over x plus 3 squared. Oftentimes the quotient rule isn't the best choice if one of these is a number. But let's go ahead and try it. This will be p, and this will be q. For our quotient rule, we need p prime and q prime. Well, derivative of 10 is 0. For q prime, this is the chain rule, the general power rule. We've got parentheses to a power. Take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. So that gives us 2 times x plus 3, 2 minus 1 is 1, times the derivative of x plus 3 is 1. So that just gives us 2 times x plus 3. Okay, quotient rule. We've got p prime q minus p q prime over q squared. So for our second derivative, let's plug in everything. P prime we said was 0. 0 times q, which was x plus 3 squared, minus p, which is 10, times q prime, which is 2 times x plus 3. All over x plus, or q squared, so we're going to have x plus 3 squared raised to the second power. Well, 0 times anything drops away, so that disappears. We got negative 10 times 2 is negative 20 times x plus 3. And when you raise one exponent to another exponent, you multiply them together, so that gives us x plus 3. 2 times 2 gives you 4. Now we got negative 20 times x plus 3 over x plus 3 times x plus 3 to the third power. We can rewrite it that way. Because this is x plus 3 to the first power. If I were to go backwards, x plus 3 to first power times x plus 3 to the third power, you add the exponents, which will give us a 4. And we notice that the x plus 3's cancel there. And you get negative 20 over x plus 3 to the third power. And you see that gives us the same answer as that. Is it any more work? I probably wouldn't normally show this last step right here. So, maybe about the same amount of work. This one doesn't probably save you anything. But anyway, this is our answer. Negative 20 over x plus 3 to the third.